Before we get into the video, thank you to everybody who's been supporting and subscribing. Everything we're going to go over today is also going to be in a PDF format that you can access by supporting me on Patreon. As you may or may not know, creating content like this does have an opportunity cost. And I'd really appreciate it if you sign up for just $5 a month. And this will give you access to download this PDF guide with everything we're going to go over in this video. You can also purchase this guide for a one-time purchase of $7. Link in the description. Back to the video. You guys, I broke out the fancy shirt for this one. Huh? All right, back to the video. So if you're watching this video, you more than likely have a Homelab.
Cause I have $30,000 in credit card debt.
And in your Homelab, you're running applications. And if you haven't already configured TLS certificates or PKI within your Homelab, then when you navigate to these applications in your web browser, or when you try to use maybe a CLI, command line interface tool, to connect these applications, you're greeted with something like X509 error, TLS insecure, connection is private, connection not secure. And specifically in the browser, you'll probably see like connection not secure in the top left next to the address bar. And if you click on it, you'll see something along the lines of certificate is not valid. In this video, we're going to be using HashiCorp Vault to configure certificate authorities for our Homelab so we can issue TLS certificates for our applications. If you're not familiar with what HashiCorp Vault is a secrets management tool in which we can manage different kinds of secrets, issue secrets, rotate, dynamically generate secrets. I realize that this video may not be for everybody. Not everybody wants to manage a certificate authority in their Homelab, and that's okay. One of the more popular ways to manage TLS certificates and PKI for a Homelab is to go to a domain provider and purchase a domain, something like lab.com, and then go to a publicly trusted certificate authority, something like DigiCert or Let's Encrypt, and get a certificate issued from them, and then configure a reverse proxy with the TLS certificate in your Homelab, thus not having to configure every application with its own certificate. But if you have a Homelab, and if you're like me, you like to tinker. You like to create a certificate authority and manage all the TLS certificates yourself. And let's face it, PKI can be very complicated, and if you don't use it, you lose it. So managing my own certificate authority and intermediate certificate authority helps me keep fresh on my PKI knowledge. So the first thing we're going to do is we're going to install Vault and we're going to initialize it together. Now Vault runs on Linux, Windows, and Mac OS. You can run Vault on an existing PC, but for the purposes of this video, I'm going to start with a fresh and clean environment. So here I am in Proxmox, and I'm going to create a virtual machine. Now, as you can see, I already have a Vault VM running, and it's not really doing anything, but it's sitting at a steady 1.7 gigabytes of RAM. So make sure that if you're creating a VM for this, you're allocating at least 2 gigabytes of RAM. My VM is almost done configuring itself. So my VM is done installing Ubuntu, Vault 2 here. And now what I'm going to do is I'm going to SSH into the server. I had the open SSH software installed and it is running. So I should be able to connect via SSH now. And I'm only doing that because I don't have copy paste configured for my Proxmox VMs yet. So using whatever software you choose, I choose to use Visual Studio Code. I'm going to open a terminal here, which is just going to open a PowerShell terminal here on my Windows machine. I'm going to SSH user at, and then whatever my IP address was. So let me get that IP address real quick. And that is going to be 192.168.50.9. All right, so I'm in. Now I can copy paste. So with my Linux VM spun up, now I can come over to the installation documentation for Vault. And I'll leave a link in the description to this page here, but they have a little video to walk you through the process. And if you scroll down, you'll see Mac OS, Windows, Linux, right? And if you're on Linux, they have different options for Debian, RHEL, Fedora, Amazon Linux. And I'm on Linux, so I will pick my distribution, and I am on Ubuntu. So I'll start copying and pasting these commands here. So we're going to copy this command. We're going to update our package manager and make sure wget is installed. We're going to go ahead and download the keyring for the GPG key. I'm going to overwrite mine because I made a mistake the first time I did this. We're going to verify the keyring. Looks good to me. Comes from HashiCorp. We're going to make sure the HashiCorp repository is added to our package manager. And then we're going to update our available packages and install Vault. And that's it. So now Vault should be installed. So we can verify this by running something like vault -- version and I can see that I have 1.16.2 installed. So I'm having camera difficulties, so you will no longer see me in the bottom right-hand corner, but with Vault installed, now we can configure Vault to run. So it should be noted that while we can run Vault server-dev command to just spin up a dev server, we're not going to do that in this video. The first thing we need to do is we need to create a Vault configuration file. So I'm going to create a config.hcl file here. It doesn't matter what you name it. It is in HashiCorp configuration language, and we will go ahead and provide this configuration here. Now, what are we looking at? Well, path is a path on the system where Vault is installed, where we would like to install our Vault data. If we didn't have this, then every time Vault restarted, we would have to initialize it and unseal it, and we would lose all of our data. So go ahead and provide a path. I'm actually going to use, because I'm in Linux, opt/vault. Now, because I'm telling Vault to store all of its data here, I need to make sure opt/vault exists. So I'm going to go ahead and make opt/vault. That is where all my Vault data will go. The address. Now you need to decide, are you installing Vault on the same PC that you're accessing it from, meaning localhost? If so, provide 127.0.0.1 for address, API address, and cluster address. However, in my case, because I am on a remote host, a virtual machine, I need to provide that IP address. So that's what I'm going to do. And then yes, we want to enable the UI. So now I'm going to take this configuration.hcl, create it on my VM here. Now I'm ready to start Vault using this configuration file. So to do that, we're going to run Vault server-config equals and give it the location of the configuration file on our system. I'm already in the directory that contains config.hcl, so I'm just going to pass the file name, and then Vault will begin to start. Now you will see Vault running here in the terminal. Ideally, you would create something like a systemd service on Linux or Mac, or a Windows service using something like sc.exe, so that it can be a long-running service that starts when the host starts or restarts, and you don't have to keep it running. You can, here in the terminal, you can push it to the background and have it running all the time. But that's beyond the scope of this video. So with Vault running, there's a few things we now have to do, and one of those is we have to initialize Vault. So I have a second terminal over here to the same virtual machine where Vault is running, and in this terminal I am going to set an environment variable called Vault addr for Vault address, HTTP, and then the address and port of my Vault application. And that is how we are telling the Vault command line interface how to connect to our Vault server. So to initialize Vault, we need to run Vault operator init. And it might hang for a few seconds, but once you get the output back, you'll get 5 Unseal keys. And make sure you save these somewhere. So I'll create a new file, Unseal keys, and make sure you also save the root token, because we need the Unseal keys to unseal Vault, and we need the root token to log in to Vault. And we get 5 Unseal keys because we need at least 3 of these by default to unseal Vault so we can begin using it. And in a real world, you would divide all of these keys up, give them to different people, put them in different locations. And in the event of emergency, you can seal Vault. And then when you need to unseal it, you would go gather all of the required amount of keys, in our case 3, and then unseal Vault. So you want to make sure if you're going to keep these around long term, you store all of these somewhere safe. Now, after we initialize Vault, we need to unseal Vault. So we're going to run Vault operator unseal. And then we're going to pick one of these keys. It doesn't matter which one. And we're going to provide it. And now you'll see the total shares is the number of keys that were output when Vault was initialized. And the threshold is the number we need to provide to unseal. And this is our unseal progress. So we've provided one of the 3 required keys. So we're going to run vault operator unseal again, and we're going to pick again one of the 5 keys. And now we're unseal progress 2 of 3, and we're going to run it one more time, pick a new key, provide it, and then we can see that vault is sealed false because now we have unsealed vault. So now we should be able to access vault in our browser. So in your web browser, go to http:// and the address of the vault server that you configured in the configuration file. So mine was 192.168.50.9 and port 8200. Now, if you're accessing Vault from the same system that your web browser is on, you can just access this on localhost port 8200. But you'll be presented with the login screen, and the authentication method will be token, and we need to go ahead and grab the root token we were provided when we initialized Vault and provide that in order to log in. All right, and there we have it. Now we've logged into our Vault application, and we are ready to begin configuring our certificate authority. Now, when you first log into Vault, you will be presented with this screen. And on the left-hand side, you will have secrets engines. Go ahead and click on that and click Enable New Engine. There's a bunch of different secrets engines, but the only secrets we care about for this video are PKI certificates, so go ahead and choose that. For the path name, you can keep it PKI. You can name it whatever you want. I am going to name it root CA. And for the max lease TTL, this is essentially how long are these certificates going to be good for from the root certificate authority secrets engine, and I'm going to leave it at the default 3650. Go ahead and expand method options and give this secrets engine a description. So this is my root CA for my Homelab, and then click Enable Engine. Now when you go to secrets engines, you will see your additional PKI secrets engine here, and we're going to click Configure PKI, and we're going to choose Generate Root. So what we're doing here is we're generating a certificate and a private key. Now for type, we're going to choose internal, and common name is going to be the domain name of your lab, right? So if my domain was home.com, then that is what I'm going to put for common name. Issuer name is the name of the certificate authority that is issuing the certificates, and I'm just going to call it Vault Root. Not valid after, I'm going to set that to the same 3650 days. That was the max TTL that was set on the secrets engine when we enabled it. And then the backdate validity is essentially, once I issue this certificate, how long in the past is it good for from the current date. For format, we're going to keep PEM, and then we're going to scroll all the way down here to issuer URLs. And we're going to provide HTTP, the IP address, so in my case 192.168.50.9/v1/PKI/CA for the first one. And then we're also going to paste those into each of these, but we're going to change the last part of the path. So this one will be CRL, and this one will be OCSP. And then we're going to go ahead and click add, and hit done. Okay. So now you should see this screen. Now, when you get to this page, you want to click this button here, and you're going to get this error more than likely if you're following along with this video. Now, I did not know it when making this video, but in Vault 1.16.0, they introduced a change in which if you are not using TLS, HTTPS, you will not be able to use the Clipboard UI function because it requires a secure context. So how do we continue on working then if we haven't configured TLS? And I don't want to configure TLS because that would make this video longer than it's already going to be, right? So what we can do is when you're on this page, right, go ahead and just click on Secrets Engine, click back on your root CA, click Certificates, and then click on that certificate. That the only one you're going to see is a bunch of, it's just a random identifier. And then we're going to download that certificate. And then we're going to take that certificate. I'm going to open it up in like Notepad or something because I'm on Windows right now, and I'm going to copy it. And I'm going to store it somewhere safe. So I'm going to call this root cert.cert. All right, and there is my root certificate authorities certificate. So back on the secrets engine page, now we need to configure, well, we don't need to, but we are going to configure what's called an intermediate certificate authority or intermediate CA. So hold up. Why do we need an intermediate certificate authority? Why not just issue all of our certificates for all of our applications from the root certificate authority? And the answer to that question is for security and scalability. See, when we create a root certificate authority, we could issue all of our certificates against that. But if the private key for our certificate authority becomes compromised, a bad actor gets a hold of it, every certificate that was issued by that root certificate authority now needs to be revoked and reissued. And this could cause a lot of problems. Imagine you worked in an environment where you had one root certificate authority and 10,000 applications, and each application needed its own certificate. If your private key was compromised, you would have to revoke all of those certificates and reissue all of them. So typically, when a root certificate authority is created, an intermediate certificate authority is created with the ability to issue certificates on behalf of the root certificate authority. And multiple intermediate certificate authorities will be created to issue certificates on behalf of the root certificate authority. And the root certificate authority will be locked away behind a door in a secure location, and the private key will be secured. And when somebody requests a certificate, they go to an intermediate certificate authority to get a certificate. So now imagine you work in an organization and you have 20 intermediate certificate authorities. Those 10,000 TLS certificates you need for all of your applications, well, instead of going to one CA for all 10,000, now we can go to one of the 20 and split them up equally divided amongst the intermediate certificate authorities. So now if one of my intermediate certificate authorities' private key becomes compromised, I only need to revoke and reissue the certificates issued from that intermediate CA. And the other reason we do it is for scalability. The more intermediate certificate authorities we can add, the more requests for certificates we can handle. So I'm going to click Enable New Engine, and again, I'm going to click PKI certificates, and I'm going to call it Intermediate CA. I'm going to leave the max lease to 3650 days, and I'm going to expand method options and add a description. This is the intermediate CA for my home lab. Okay, and we're going to enable that engine. And now we're going to click Configure PKI to configure the intermediate certificate authority. We are going to choose Generate Intermediate CSR. And what we're doing is we're creating a certificate signing request and a private key for our intermediate. And then we're going to give that to the root certificate authority and get our certificate for our intermediate certificate authority created from the root. And then all of our other certificates will be issued by the intermediate certificate authority on behalf of the root certificate authority. So we're going to configure type of internal. And for common name, again, I'm just going to use my lab's domain name, lab.com. Format is going to be PEM, and I'm going to click generate. Now, if you attempt to click the UI clipboard copy function here, you're going to get this error if you've been following along and you use the same configuration file that I did with TLS disabled true. And that is because in Vault 1.16, which I am using to record this video, they introduced a requirement for secure context in order to use the UI clipboard copy button here. So because we haven't configured TLS, it's just not going to work. So one way around this is we can just triple click into here and copy the entire thing to our clipboard using right click copy or just Control C. So with my intermediate CSR in hand, right, it's copied. I'm going to go ahead and create a new file called intermediate CSR.pem. Name it whatever you want, but just make sure you know it's the certificate signing request. And I'm going to paste that in there. Now there's an issue with this because of the way we've copied it. You can see that there are some leading and trailing spaces all throughout this entire thing. And that is a no-no. We can't have that. So we have to get rid of that. So how do we do that? Well, there's this command here that we can run in bash. So cat and then the file intermediate CSR.pem. So we're going to output that, and then we're going to use sed to remove all of those leading and trailing spaces. So I'm going to go ahead and run that from the same directory where this file exists. If you're not in the same directory, just add the relative or the full path, and voila, we get the correct output formatted the way we need it for our use cases. So I'll copy that and I will replace that. And that is now a valid formatted certificate signing request. Now, if you're on Windows, highly suggest you get access to bash, whether that be through git bash or WSL to run this command. If you really insist on using PowerShell for this video, I would just ask ChatGPT, what is the equivalent PowerShell command to this bash command? All right, so I'm going to hit done, and I'm going to go back to secrets engines. Now I'm going to go back to the root certificate authority, and we're going to click on issuers, and we're going to click on the issuer we created when we created the root certificate authority, and we're going to click sign intermediate. And we're going to provide that certificate signing request here. The common name, again, just choose the domain name of your lab. So mine's home.com. And for TTL, I'm going to choose the same TTL I've been choosing throughout this whole video. I'm going to enable backdate validity for just 30 seconds. And I'm going to choose PEM bundle this time for format. Now, there are a lot of different options you can provide here, and I'm not going to go over any of these in this video, but feel free to check out the documentation if you're interested in that. And we're just going to hit save. Now, as long as your certificate signing request was formatted properly, you will end up on this screen with your certificate, your issuing CA, and your CA chain. Now, the certificate is the certificate of the intermediate CA. The issuing CA certificate is the certificate of the root CA that issued the intermediate certificate. And the CA chain is the chain or all of the certificate authorities within the chain that we're issuing these certificates. So in our case, all the CA chain is a file that includes this one and this one. Now, all we need is this first one, the certificate here, because all we requested was a certificate for our intermediate certificate authority. So using the same technique we did a minute ago, I'm gonna not using this because we haven't configured it, and you're gonna get this error. Triple click in here, copy the certificate. Go ahead and store this somewhere as the intermediate cert. We'll just call it .pem, or we can just call it .cert. Doesn't really matter. We can't have this. Again, we have the leading and trailing spaces in our certificate, so we need to remove those. So running that same command we ran earlier, but this time replacing some things. We want to remove this, so it just says begin and end certificate, and we want to choose the proper file this time, so intermediate cert.crt, and there we go. So we're going to go ahead and copy that, and we're going to paste that in there. And that is our intermediate certificate authority certificate. So the next thing we're going to do is we're going to click back here on Secrets Engine, and we're going to go again, and we're going to select our intermediate certificate authority, and we're going to go to Configure PKI, and we're going to click Import a Certificate Authority. Now we can hit Browse here and navigate through the file system to our certificate. That's fine if you want to do that. I'm going to go ahead and click this toggle here, Enter as Text, and I'm going to paste my intermediate certificate here this way, and I'm going to hit Import Issuer. And if all goes well, if everything's formatted properly, you will end up on this page with no errors. Just ignore this over here. You can go ahead and hit Done, and now you'll see we have two issuers underneath our intermediate CA. We have our root and our intermediate. Now we have an intermediate certificate authority. We are ready to begin issuing certificates from the intermediate certificate authority. But in order to do that, we have to create a role. So go ahead and click on roles, and we're going to hit create role. And a role will be configured to issue certain types of certificates. And we will set a bunch of permissions, such as what can this key be used for? What kind of certificates can we generate with this role? So I'm just going to call it issue Homelab certs. Now, before we configure anything else, we are going to go to the top left here, this little terminal icon. We're going to click on that, and that will open a terminal in our web browser. So we're going to type read dash field equals default intermediate, and we're going to choose the name of our intermediate certificate authority secrets engine path that we named it. So if you look up here where my mouse is, it says intermediate underscore CA. That's what we're going to enter here. And then slash config slash issuers. Now you're going to get this unique ID here, and go ahead and copy that. And just put it somewhere safe for now. So I have a file here called notes. And now you can go ahead and close this terminal. And we're going to use that in a second. And now for issuer ref, we are going to turn off use default issuer. And now that issuer ID that you just copied, go ahead and make sure that's selected. We're going to move on to TTL. We're going to choose 3650 again, days. So this is how long the certificates that are issued by this role will be valid for. So any Homelab certificate I issue will be good for 3,650 days. I'm going to leave backdate validity alone. Now we can choose which domains are permitted to have certificates issued against them with this role, right? So if I say home.com, that means I can request or issue a certificate for any something home.com, but I couldn't issue it for anything else. So I could go ahead and add that. And if I have more, I can add and add and add. I'm just going to leave that one. Hey. And it should be noted that this is optional. You don't have to provide this. If you don't provide this, people can issue, or you, it's your home lab, can issue a certificate for any domain using this role. Go ahead and click allow subdomains if you want. You don't have to, but if you're following along with this video, just go ahead and click it. So this specifies, if clients can request a certificate with a common name that is like a subdomain, right? So I am my domain for my lab is home.com, but maybe I wanted to issue a certificate for a subdomain like lab.home.com or dev.lab.home.com, right? If I enable this, I have the ability to do that. If not, I can't do that. And also enabling this allows us to create wildcard certs if we also allow wildcard certificates, which would be if I wanted to issue a certificate for any application in my lab, I would just do like *home.com and I would get one certificate that I could use for every application in my lab. I'm not going to do that because we're not going over wildcard certificates, but just know that if you don't check this, then even if you click this, right? So this configuration right here, you will not be able to issue a wildcard certificate, even though allow subdomains is configured. You would have to have both of these configured. We're going to make sure allow localhost is clicked. This just means, if someone wants to request a certificate that says localhost.home.com, they will be allowed to. And enforce host names, we're going to choose that. And this just says we are only allowed to provide valid host names or IP addresses for common names or DNS subject alternative names, which we'll go over in a second. Go ahead and expand subject alternative name options or SANS options and make sure, if you want to. So, when you go to your browser and you type in an IP address like we are here with Vault 192.168.50.9. Well, if we don't enable this, when we issue a certificate with this role, if we wanted the host name, if we wanted this to be a valid, trusted address, right, where it wouldn't give us the HTTPS warning without a host name, we wouldn't be able to issue a certificate for an IP SAN like this unless we had this box checked. So I'm going to leave that checked. And if yours isn't checked, please do check it. And then go ahead and expand additional subject fields. Now, I'm not going to go over all of these, but there are some of interest here. So organization, right? If you click on a certificate in your URL bar and you look at the contents of it, you can typically see who issued it, what country it came from, what city it came from. And this just helps give people information about the people issuing their certificates. So I'm going to choose organization. I'm just going to say the lab, and the country, we'll just say USA. For city, we'll just say South Park, right? And then for state, we'll say Colorado, CO. Street address, 12334 City Walk. And for postal code, 12345, right? These, I'm just making these up as I go. Make sure you hit add for each one of these, please. Otherwise, they will not be included with your role. And then just go ahead and create. All right, so the role has been created. We can see that any issued certificates are good for that 3,650 days or 9 years, 11 months, and 29 days. Okay, and that's it. We are done configuring our certificate authorities. Now we can issue a certificate for an application in our Homelab. So I'll show you how to do that. We're going to use Heimdall as an example, and then I'll show you how to make your browsers trust your Homelab certificate authority. Now, I have an application here running Heimdall in my Homelab, and it's running on Docker in a Docker container. And so I'm going to go to my host file on my system, or if you have a router at home or a DNS server, this is where you would typically do it. But for quick demonstration purposes, I'm going to go ahead and add heimdall.home.com to my host file, and it's pointing to the same PC that I'm on, localhost. So now I should be able to resolve the DNS address heimdall.home.com to this local PC where Heimdall is running. So in my browser then, I will go to https://heimdall.home.com port 6005, because that is the port that I've configured. And we can see that it is not secure, and I'm going to accept this risk. And so I'm in the Heimdall application. If you're not familiar with Heimdall it's simply just an application where you can host like a dashboard and configure different tiles to point to different apps. And we can see by the little exclamation point up here that, the site is not secure. So I need to generate a certificate for this application in my Homelab. So I'll go to Vault and I'll go to my intermediate certificate authority, and I'll go to roles, and I'm going to click on that role that we created together earlier. And we're going to hit generate certificate. Now the common name, I'm going to do heimdall.home.com. And I just want it to be good for, this many days. And I'm going to choose format PEM. And for private key format, I'm going to choose DER. Now it should be noted that what you choose for these two options, PEM or DIR or PKCS8, is on an application by application basis. You want to make sure you check your application docs before you do this, but for most applications, this combination of PEM and DIR, that'll work out for you. Now, expand subject alternative names here, and I'm not going to exclude the common name from the sans, right? All that means is if I clicked this, I would have to add heimdall.home.com as a subject alternative name, but I'm not going to click that, so I don't have to do that. It's already included. Now, what if I wanted to resolve this on another name, like, I don't know, Jaime like dash.home.com, right? So I add that, and then maybe, that's another DNS name, so dash.home.com, right? So I'll save that, and if we check in the browser, we should be able to resolve https://home.com, and we do. Right, so this just ensures that if I have any other names I would like to access this application by, that they're trusted, they're included in this certificate. IP sans, right? So IP sans is just saying, if I attempt to access this application at an IP address, right? So I'll go back to Heimdall. And if I were to attempt to access this at HTTPS, the IP address, and then the port, right? That's not trusted either. But if I want to be able to do this and have it trusted by the certificate, I would need to add that there as well. And then we're not going to go over these other two, and we're just going to hit generate. Oh, something went wrong. So this happened because my TTL was longer than what was permitted by the intermediate or root certificate authority that I'm attempting to get this certificate from. And this is because I configured that before I'm requesting the certificate. So to avoid this problem, I could just do 1 day before today, right? And that would work. But you know, as the clock ticks down, that number is going to go down and down and down. So maybe just every time you pick one, just issue it for like a year. And then for the next 9 years, you'll never run into that problem. Now, we've been issued our certificate. And you really want to pay attention here. The private key is only available once. Make sure you copy and save it now. So typically, all we need for an application is the certificate and the private key. Sometimes we need the CA chain as well. So what we're going to do is we're going to copy certificate, CA chain, and private key. So if you've been following on with this video, as I'm sure you have, you'll get the dreaded API clipboard error if you attempt to use the copy to clipboard UI button feature. You can click download here, but that's only going to give you the certificate and not the private key that we need. So go ahead and double, triple click, copy. And then we're going to go ahead and save this certificate somewhere. So this is my Heimdall.cert. And again, just like before, we're going to get rid of the leading and trailing spaces because this is incorrect formatting. So we're going to run that same command again, but we're going to pass in the name of the correct file. So Heimdall.cert. And there we go. We will copy that. And we will replace that. Okay, and now I'm going to do that real quick with the private key and the CA chain, and then I'll come back to you. So I'm finishing up with the private key right now. So as you can see in the command, I've changed the wording to match RSA private key. So I'm going to go ahead and copy that and save that into my Heimdall key.pem. All right. So now I have my Heimdall key, my private key, my Heimdall cert, and my CA chain that was given to me when I requested my Heimdall cert. So these are the two that I need for my purposes to configure my Heimdall application to be trusted by TLS. So in Heimdall, I'm just going to inspect the certificate up here. I'm going to look at more information. I'm going to view the certificate, and I can clearly see that, you know, it was not issued by my Homelab. So this is just for a before and after comparison. Now, what you need to do is find your application's settings or configurations for TLS. In my specific case, Heimdall, right? All the files for my Docker container for Heimdall are mounted into a folder on my local PC called Docker Volume Heimdall in my F drive. And I have an Nginx folder here, which has like the web front end for Heimdall. And if I look in the SSL.configuration file, right, if I look closely, I can see that the SSL certificate and the certificate key are in the keys folder. So I'm going to go to the keys folder. And there is a cert and a key here. And these are the ones that it's currently using. So what I'm going to do is I'm going to make a backup. Always make backups. Backup. And I'm going to take the cert and the key, and I'm going to put them in here. And then I'm going to take the certificate and the key that Vault had issued us, right? So my Heimdall cert. And I'm going to create a new file. And I'm just going to name that cert.crt. Because that is what Heimdall is expecting. That's what it's looking for. So I'm going to go ahead and open this in Notepad real quick. Paste that in there. Save. And that's the cert. Now we're going to do the same for the key. So if we look at backups, we're looking for cert.key. So we're going to create a file. New text document. It's going to be cert.key. And we're going to open this up. We're going to find the Heimdall private key, and we're going to copy and paste that in there. All right, now all I need to do is restart Heimdall real quick. I'm going to stop it. I'm going to start it, and Heimdall's restarted. So let's check it out. Let's see if it's working. Right, so I'm going to go advanced, accept the risk. And now we're still showing insecure, but now we should be using the correct certificate. So if I have view certificate, oh, look at that. This is the information we configured when we set up our role. All right, so this is the Heimdall.home.com certificate, common name home.com, right? The subject alternative names are dash.home.com and Heimdall.home.com, right? So my application is using the correct certificate, but it's still not trusted. My computer does not trust the certificate authority that issued this certificate, and that's what we're going to remedy now. Now we're going to go over the process of getting our computers and our web browser to trust our certificates. So the process to do this is basically whatever operating system you're on or browser, you have to configure it to trust the intermediate or root certificate authority or both that issued that certificate. This is going to differ from operating system to operating system. Obviously, Windows is going to be different from a Linux-based operating system, and a certain Linux distribution will differ from another Linux distribution. And then in some cases, the browser needs to be configured in addition to the operating system. For instance, with Google Chrome, if you install the root certificate into the Windows operating system and make it trusted, Chrome will pick that up from the same certificate store on the Windows PC. However, Firefox on the same Windows PC will not, and you have to configure Firefox in addition. So we're going to go over how to take a Debian-based or Ubuntu operating system and install our root and intermediate certificates in there so they can be trusted. So here on this Ubuntu operating system, I'm going to open up Google Chrome, and I'm going to go to https heimdall.home.com 6005. Oh, not resolving anything. Got to add that to my host file. Oops. You won't run into this issue if the application in question doesn't have to be Heimdall. I'm just using Heimdall as an example. It's already configured in your DNS server at home. There we go. Reload page. And we can see the certificate is not trusted. And it's going to take a bit of work to get it trusted with Chrome, but just bear with me. So on a Ubuntu or a Debian-based operating system, there's a specific place we have to put our certificates. So we're going to go to user local share CA certificates, right? And there's nothing in here. And I'm going to go ahead and add my Vault root certificate. So my root certificate authority certificate. And I've got that saved on my PC from earlier when we created that together. And I'm going to create another one called Vault intermediate .cert. And I'm going to do the same thing, paste the intermediate certificate authority certificate into here. So now I have my root CA and my intermediate CA certificates on the system. And now all that's left to do is to install them. But before I do that, just so we know that this works, right? When I update the system, Chrome is not going to automatically update. Not on a Linux-based operating system. So I'm going to run curl https and then the name of the application. And I need my port. This should return an X509 error because my computer does not trust the root certificate authority or intermediate certificate authority that issued the cert for Heimdall.home.com. And there we go. SSL certificate problem. Unable to get local issue certificate, blah, 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 right? So now we're going to go ahead and update the system to install these, and we'll see what that looks like again. So on a Debian or Ubuntu based system, all we need to do is run update-ca-certificates, and we're going to install these two certificates in this directory, and we can see that 2 have been added. All right, so now we're going to run that command curl one more time, and this time we don't get an X509 error. We actually get the response we expected because now our computer trusts the certificate. However, Chrome over here does not trust our certificate. Now, if I wasn't having an issue with Firefox on here, I would show you how that actually works. But what we can do is install it in Chrome. So we're going to go over to the 3 dots in the top right, and we're going to go to settings. And then over here on the left, there are some options we can choose, and we're going to look for privacy and security. We're going to go to security, and we're going to click on manage certificates. Now we're going to click on authorities and we're going to hit import, and we're going to navigate to user local share CA certificates. And this is where these two are. So we'll go ahead and do the root, and we will say, yes, we trust it for identifying websites. And that's it. So I'm going to go ahead and restart Chrome. And we're going to go back to HTTPS, heimdallhome.com. And now we don't get an error. We say connection is secure. So now Chrome trusts our certificate. All right, so we just went over Ubuntu Debian-based operating system. Now let's go over a Fedora operating system. So this is going to apply to stuff like CentOS, Red Hat Enterprise Linux, and Fedora. And then we'll go over Windows. So if I open up a Fedora operating system here, I'm going to go ahead and open up a terminal. And I'm going to make it so I can actually reach Heimdall.com. But again, you won't have to do this as long as you've configured whatever application you're trying to do this for in your home DNS server. For Heimdall.home.com. So if I try to curl the application at HTTPS, and this is important, it needs to be HTTPS, Heimdall.home.com, and then the port, right? I get an SSL error, X509 error. And this tells me that this operating system doesn't trust my certificate that was issued by my root certificate and certificate authority. And then I'll open up a Chromium web browser and go to HTTPS, Heimdall.home.com, and the port, and not trusted. So let's go ahead and configure this operating system to trust our certificate. No, to trust any certificate issued by our root CA or our intermediate CA. So these steps are going to be very similar to what we did on Ubuntu. The only difference is the location in which we put the certificates is now going to change. So we're going to grab our root certificate authority certificate and our intermediate certificate authority certificate, and we're going to go to etc pki ca trust source anchors. And there should be nothing in here. This is your first time doing this. And I'm going to go ahead and create vault root.cert, and I'm going to paste my root certificate authority certificate in there. And then I'm going to create vault intermediate. And I'm going to paste my intermediate certificate in here. And so now I have my root and intermediate certificate in here. And so again, just like we did for the Ubuntu or Debian-based operating system, we're going to run update-ca trust. And that's going to install these two certificates. So now if I were to run that curl command again, I don't get an error about SSL anymore. And then this time on this operating system, if I were to restart Chrome, now that I've installed that certificate, and go to Heimdall, we can see that it's secure because Chrome is picking up the certificate from the proper location. So you can see how this kind of differs from operating system to operating system, browser to browser. So that's it. My Fedora, and you can do this same exact procedure here for CentOS or Red Hat Enterprise Linux operating system, now trusts my certificates. So now let's go over how to make our Windows operating systems trust our certificates issued by our certificate authorities. So here I am, I have a terminal open and I have Firefox and Chrome. And so you can see Firefox does not trust the certificate, Chrome does not trust it. And I'm going to run here in my terminal, and this is just a PowerShell terminal, curl https heimdall.home.com 6005. So we can see that, the underlying connection was closed, could not establish a trusted relationship for TLS. So that's because Windows, when I'm running the curl command, it's not trusting the TLS certificate that Heimdall is using. So in order to remedy this, we are going to install the certificate on Windows. So what you can do in your search bar here is you can just search for Cert. And one of the things that will pop up is Manage Computer Certificates. And this box is going to appear. And this is the certificate store for your Windows PC. So what we're looking for is the Trusted Root Certificate Authorities and the Intermediate Certification Authorities. So go ahead and expand Trusted Root Certification Authorities and right-click on Certificates, All Tasks, and hit Import. And for our local machine, right, we're going to go ahead and we're going to browse to our root certificate. And we're going to go ahead and choose it. We're going to hit next. Make sure this says trusted root, certification authorities, next, finish. Import was successful. Okay, so my root certificate authority certificate was imported. So now we're going to do the same thing, but under the intermediate certification authorities, certificates, all tasks, import, local machine, next, browse, intermediate cert. So this is the certificate that was issued when we created our intermediate certificate authority. Next, we're going to place it in the intermediate certification authorities location. Next, finish, import successful. So now I'm going to run the curl command again, and we no longer get an error because now our Windows PC trusts our certificate because we've told it trust any certificates from this certificate authority. Now, Chrome, if I refresh, still doesn't trust. Firefox still doesn't trust. That's because you have to restart these things, right? So I'm going to go ahead and restart. So this is Chrome, and we can see that connection is secure. And let me open up Firefox again, Heimdall, and connection is secure. So now my Windows PC trusts my certificates.